Alright, now thanks for tuning in. In this video sizokhuluma ngo question 12 Euclidean geometry, which is the last question for this November 2016 mathematics paper 2. In the description box of this video uzothola ama links for other videos engiwarecordile for this question paper. So lana with question 12 we have two questions, 12.1 where we have to prove a theorem, and then sibe no 12.2 where kwamele siperform ama calculations, especially okay la ku 12.2 we are actually proving, right? We are proving ama parallel lines, a cyclic quad as well as a tangent. So asiye ku 12.1 and prove this theorem. Use the diagram below to prove the theorem which states that EFG is equal to EDF. We want to prove that lama angles lawa are equal. In other words, we want to prove ilogai tan chord theorem, right? Okay, 12.1 12.1 sizothikela. Into yokuqala soyenza, we are going to do a construction, right? Construction. The construction lena siyenza by drawing a diameter AOF. Yes, okay, low, this is AOF, and then we join obani AD. The reason why senza logo is so that sizokwazi ukuba nani ne bow tie, right? And then after doing this construction siyabona ukuthi okay, the construction lena is in fact dividing lama angles la. Yabona le line leli I create angle 1 and 3 as well as angle bani 2, and then nasjoin now AD sithole angle 1 as well as ubani angle 2. Remember sifuna ukuprove ukuthi lama angles are in fact equal. So after doing the construction we see that in other ngamanye amagama sizama ukuprova that angle D2 is equal to angle bani F2. Enye indlela yokubheka lelo kanje le problem, right? Okay. Now we have iloga bow tie lana, and then we also have iloga diameter. I can see that F1 plus F2 is equal to 90 degrees. F1 plus F2 is equal to 90 degrees. Why? It's because of a tangent FG is perpendicular to diameter AF, or the radius OF, right? No tangent is perpendicular to a radius is still fine. And then D1 plus D2, the D1 plus D2 is equal to 90 degrees. Why is this true? It's because of angle in a semicircle. So D1, D2, F1, F2 yiwo ama angles ekwamele sifocus kiwo, right? Yiwo ama angles ekwamele sifocus kiwo, so that we can prove ukuthi lama angles lawa are equal to each other. So now siyaqhubeka ke manje, siyaqhubeka, and then D1 ulingana no DF. Yes, D1 ulingana no DF. Why? It's because of our angles in the same segment. Angles in the same segment. F1 no D1, right? Okay, now sekunama equations ayi 3, 1, 2 and 3. Now ngithatha le equation le yokuqala F1 ngimenza subject of the formula. Ngithatha the second equation ngenza D1 the subject of the formula. Why ngenza njalo? It's because of D1 is equal to bani D2. Now the mission la is to in fact prove ukuthi D2 no F2 are equal, and the into ezosinceda la ilama equations la. F1 equal to 90 degrees minus F2, D1 equal to 90 degrees minus D2. Since F1 no D1 are equal, siyabathatha siyaba equator ke f1 I mean d1 lo, and then lona ubani f1. 90 degrees minus f2, it's f1, and then 90 degrees minus d2 d1, right? And then the 90 degrees bazo cancel each other out. Ngoba nangitranspose alo 90 degrees to the left hand side, this one nangimtranspose ngapha yofika bo negative, then they cancel, right? And then naba cancel akusala minus d no minus f. Minus d2 is equal to minus f. Therefore, after dividing la by negative 1, I can actually see that d2 is equal to bani f2. This is how you prove Ilogaitan-Code theorem. We prove a Itan-Code theorem. You do this construction of joining of drawing a diameter AOF and joining AD all the time. The reason why we draw a law, remember, is to create a bow tie so that uzokwazi ukuprove ukuthi lama angles are in fact equal. So Tan-Code theorem siyiprova ngale ndlela. Siya ku 12.2, so let me erase and then do 12.2. Alright, 12.2. In the diagram below, BOC is the diameter of the circle. BOC is the diameter of the circle, and then AP is a tangent to the circle at A, and AE is equal to EC. Prove that 12.2.1 BA is parallel to OD. Right, I'm a parallel lines, there's no escaping this one. I'm a parallel lines or prove ngani ngama alternating angles or ama co-interior angles or ama corresponding angles. Remember lo fan corresponding co-interior alternating angles. Wa prove ngo fan, right? Wa prove ngo FUN, corresponding alternating or co-interior angles. So in order to prove lama parallel lines, we're gonna need ama value for ama angles. Okay, bheka ke, I can see ama corresponding angles between the parallel lines of BA no OD. Lama lines about to prove with a parallel. Ngibona ama corresponding angles la angle B no O1, right? But the challenge la ukuthi I don't have a value for this one as well as the value for this one, or I cannot calculate. It's going to be difficult to calculate angle B no angle O1, so that's to prove with lama angles ayalingana. Okay, ngibona amanye ama corresponding angles now amanye ama corresponding angles. Lana kuzoba very difficult ukuthi sithole i-value yale angle yala as well as the angle yala, right? We are not given any angle. If they did, bekuzoba a little bit easier nyana, but since abasiphanga, so kuzoba a bit difficult ukuthi siwa calculate lama angles lawo. Angle ODP no angle OBAP. And then ngibona nama alternating angles lawa. It's going to be difficult to calculate now. Now ama corresponding ama co-interior angles, if we had the values for lama angles or besikwazi ukwa calculate, bekuzoba a bit easier, but nakhona it's a bit of a challenge. Lana nakhona amanye ama co-interior angles, but ngi-analyze ngaze ngafika la. Oh snap. Okay, snap. Bheka ke la. This BOC is what? Is a diameter, right? Meaning the angle le BAC. Angle BAC ngingakhona ukumcalculate angle BAC. This angle ngakhona ukuyi-calculate. Why? It's equal to 90 degrees, right? Ama corresponding angles, these corresponding angles, we need to show ukuthi E2 no angle BAC are equal. That's what all lawo ma angles with are equal. It means lama lines BA and OD are parallel to each other. Now BAC is equal to 90 degrees because of any angle in a semicircle, in a semicircle, and then E2, angle E2 yena na it's equal to 90 degrees. Why ngisho njalo? Because of the line that is drawn from center to midpoint of a chord, to midpoint of a chord. Now from center to the midpoint of a chord, I shall say this is equal, this line AE is equal to EC. So the line leli bisector this chord, which is theorem 1, right? E2 lingana no BAC. So lama angles now ayalingana, sesikhombisile ukuthi lama angles ayalingana la. If when they are equal, therefore the conclusion esingayenza ukuthi okay, now BA parallel to OD, right? Why are they parallel? Because of the proving among corresponding angles. So I go 12.2.2. We need to prove that okay, erase lana, and then since this is dealing with corresponding angles, let's move on to the next one. Now the idea is to prove ukuthi uloganje AOCD is a cyclic quad. AOCD, this shape, is a cyclic quad, right? So a cyclic quad is prove angles in a angles in a semicircle. So it's not two theorems are involved by a cyclic quad. Opposite angles in a cyclic quad are supplementary. Angle yala ngabe benginayo ne angle yala ngabe benginayo bengizo add and show ukuthi they are supplementary, or lama angles lawa bengizo add ngikhombisa ukuthi they are supplementary. Now since asinama angles, I'm just going to uyisebenzisa the theorem as well as this one, the exterior angle of a cyclic quad is equal to the interior opposite, right? Nayo besingayisebenzisa to show ukuthi this angle is equal to this one, or this one is equal to this one. So bheka ke manje la. There's also another way of prove ukuthi iloganje any given shape is a cyclic quad by using angles in a angles in the same segment are equal. This angle is equal to this one. Yabona kule shape lena sinani sine bow tie. This angle is equal to this angle, as well as this angle is equal to this angle. This angle is equal to this angle. This angle is equal to this angle. But I can only see one possibility for proving that this is a cyclic quad. Check this out. This A1 is equal to angle B. Why? A turn chord theorem, right? So le angle le ilingana na le angle le, and we just proved ukuthi amaloganje lama lines la UBA no OD are parallel to each other. Therefore these parallel lines will ngathini azoba handy ngoba we just proved ukuthi this one is equal to this one, and this angle B is also equal to O1. angle B is equal to angle O1. Corresponding angles now. Corresponding angles. Corresponding angles. Yes? Corresponding angles. Now guess what again? Guess what? Therefore, angle A1 ulingana nobani no O1 because they share a common angle. Common angle ubani B. This angle B is common between A1 nobani no O1. Now since nama angles in the same segment, therefore AOCD is in fact a cyclic quad. Why? It's because of angles. Because of angles. Okay, angles in the same segment. Angles in the same segment. So siprova kanjalo cyclic quad yethu ke. Now so 12.2.3, prove that DC is a tangent to the circle at C. Obani? Oh, DC. Okay. Go away. Well, now let's erase you. And then okay, let me also erase this and do the last question. Okay, 12.2.3, prove that DC is a tangent to the circle at C. So for prove I would do DC is a tangent la ku point bani C. Okay. Now lana ke if we prove ukuthi a line is a tangent to a circle, we use a Tan-Cot theorem. Yes? So in other words, I have to prove ukuthi B ulingana nobani no C2. Right? B ulingana nobani no C2. That's the aim. Lana we want to prove ukuthi angle B ulingana no angle C2. That's our goal again. Okay. Bheka ke manje la. Bheka ngizoyisolva kanjani this one. Sithi AOB, I mean ABO, angle ABO, alright, OBC or okay, it doesn't matter, man. Angle ABO, it's this angle. It's this angle, right? Is equal to Ntinimar. Okay. Theorem. This theorem won't confuse anyana, but okay, back. AOC, angle AOC is equal to this angle yala. This angle AOC is equal to 2 times angle B. AOC is equal to 2 times angle B, right? It's because of the angle at center is equal to 2 times angle 2 times angle at circumference, right? Angle at circumference. These angles are equal. I mean, this one is equal to 2 times this angle B, right? This angle B. Now. Usakhumbula sikhombisa especially la ku previous question siprova i-cyclic quadrilateral, then sathi angle B ulingana no angle O1. Therefore O1 angle O1 is equal to angle B. This was proved on the previous question. Therefore it it means that angle 2 uzoba equal to bani B naye, right? Ngoba angle AOC is equal to angle 2 loya, angle bani angle O1 plus angle bani O2. AOC, this angle is equal to O1 plus O bani O2, right? And then AOC is equal to 2 times bani B, and O1 is equal to B. It means O2 nayo bani B, ngoba O1 plus O2 is equal to 2B, which is the same as AOC. Alright, ngiyaphi ke nalo? Where am I going with this? Bega, the aim is to prove what? That B is equal to bani C2. And we just showed this shape is a cyclic quad. Then this angle O2 ulingana nobani no C2. It's because of our angles in the same segment. Angle O2 ulingana no angle C2. Our angles in the same segment. The angle lingana na this one. Bega ke manje C2 lo. Therefore usakhumbula sithi O2 lingana nobani no B, and O2 buya lingana nobani no OC, meaning O2 no OC, they have a common angle ubani B. Therefore angle C2 is equal to bani B, ngoba O2 lingana nobani no B, right? So C2 lingana nobani no B, B lingana no C2. This was the aim, to prove ukuthi this angle is equal to this angle. We wanted to prove a tangent line through a tan chord theorem. Therefore DC is a tangent through a tan chord theorem. But this is the converse theorem of a tan chord theorem. Whenever we prove a tangent, to sebenzisa what we call a converse tan chord theorem. So our question 12 iphelela lana. I hope we enjoyile. Nangabe we enjoyile, you know what to do. Leave a like, ungakhohlwa ukushare nabangani bakho, ungakhohlwa ukusubscribe. If ever there's anything we want to discuss concerning this question paper, asikhulume in the description box, in the comment section. Then in the description box uzothola ama links for other videos engiwarecordile for this question paper. So for now, bye bye.